So in this video we're going to look at calculating the relative atomic mass of an element. Now this will be easy if all the atoms of an element were identical. Unfortunately this is most often not the case because atoms are made up of different isotopes. In other words, they're made up of different atoms of the same element. Atoms have the same number of protons but a different number of neutrons. Now, relative atomic mass is defined as the average mass of the atoms that make up an element relative to 1/12 the mass of a carbon-12 atom. So in this example here, we've got silicon, okay, and is what we're looking at, and we're saying silicon is made of 92.2% silicon-28. Now, when it's written like this, silicon-28, that tells us the mass number of this isotope. Okay, you often would see that written on the periodic table, or more normally like that, silicon with the mass number appear, 28. Atomic number would be down the bottom, mass number at the top. So we've got silicon-28 and we've got silicon-29 and silicon-30, so we would write it like that. Silicon-28, silicon-29, silicon-30. Now, we can look at this and we can see most of the atoms are silicon-28 atoms. So the relative atomic mass of this sample is going to be quite close to 28 because most of the atoms are silicon-28. It's going to be a tiny bit heavier than 28 because we've got some 29 and some 30. So my best guess on this one is about 28.1 right now. So let's do the maths and see what it works out at. Now the mass for this, you need to learn this formula. Okay, it's the percentage abundance multiplied by the mass, okay, for each isotope. Okay, so we're going to bracket that off, so we must learn that. And then we add that to the next isotope. And we've got 3 isotopes here in total, so we're going to have to write this out 3 times. Okay, percentage abundance multiplied by the mass of the isotope, plus the percentage abundance multiplied by the mass of the isotope. Now, if you've got 2 isotopes, you need to write this out twice. If you've got 5 isotopes, you need to write that out 5 times. So percentage abundance multiplied by the mass, you must work that out. And then we divide it by 100 because we're working in percentage here and there's 100% in a whole. Okay, so write that first. That's your first mark, quite likely in the exam. Now we need to substitute numbers in. 92.2 times 28, percentage times mass. 92.2 times 28, bracket that up because we're going to work that out first. 4.7 times 29, 4.7 times 29, 3.1 times 30, plus 3.1 times 30, okay, divided by 100, probably our second mark in the exam. Just for doing calculations correctly, I like to work all these out now and then write this out again, but you could just cut straight to the answer if you want to after you've written that, but I much prefer just doing things a stage at a time because everybody makes mistakes in calculation, so much better to take our time. 92.2 times 28, let's do that. 92.2 times 28 equals 2,581.6 plus. Next one. 4.7 times 29. 4.7 times 29. Uh, 136.3. 136.3 plus 3.1 times 30. 3.1 times 30. So 93. Okay, divided by 100. Okay, again, I'm going to add all these 3 up now. That's going to be my next stage, but you can cut straight to the answer if you want to. I think that will be fine, but I'm just going to do it a stage at a time. So 2581.6, 2581.6 plus 136.3 plus 93 equals 2,810 equals 2,800. Let's not write it there. 2,810.9. That's what we just worked that out to be. 2,009. I'm going to divide that by 100, and then that is going to be our final answer. So let's now divide that by 100. Divide by 100%. Equals 28.109. And I said 28.1 was my best guess, didn't I? So 28.109. Now those calculations are incredibly common. So here's a 6-mark question from a previous Edexcel examination. Let's have a quick look at this. Okay, it says a sample of neon contains 90% of neon 20 and 10% neon 22. An atom of neon 20 contains 10 protons, 10 neutrons and 10 electrons. It then says describe the structure of a neon 22 atom and explain why in this sample the neon has a relative atomic mass of 20.2. Okay, so this is a 2-part question for the 6 marks. First thing it says is describe a structure of a neon 22 atom. Okay, well that's an isotope of neon, and we can see neon 20, another isotope, contains 10 protons. So the first thing to say about neon 22, okay, and we could write it like that. Neon 22 is the mass number, the atomic number is 10 for 10 protons, we could write it like that. The first thing to say is it has 10 protons, 10 electrons, because if protons are positive, electrons are negative, so it must have 10 of both. 22 minus 10 gives us the number of neutrons, because that's the mass number. Electrons have no mass, if you remember, so that means that's the total number of protons and neutrons present. If we've got 10 protons, 22 minus 10 is 12 neutrons. 12 neutrons. Okay, and we could draw a diagram of that out as well, because it says describe the structure of that atom. We could draw a diagram that out. Let's do that there. We'll have 10 protons in the nucleus, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 12 neutrons in the nucleus. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's circle that all up and call it the nucleus. Okay. Nucleus. Containing 10 protons and 12 neutrons. And then around the nucleus we're going to have orbitals or shells. The first shell holds 2 electrons. We'll do electrons as crosses here. And second shell is going to hold 8 electrons. And it's got 10 electrons in total. So 2 on the first and 8 on the second make 10 electrons. And there's our structure of our neon atom, describe a structure of a neon 22 atom. So we've done that, and this is a 6-mark question, so there is a mark. The asterisk there tells me there's a mark for spelling, punctuation and grammar. So I probably would write that into a sentence now, just explaining that with a capital letter and a full stop. And I'll probably be fairly safe of getting that spelling, punctuation and grammar mark. Now, more importantly, the calculation. The second part of this is the calculation. It's given us the answer, but it wants us to show the working. So all the marks here are for working. So the formula was, if you remember going back to our calculation license here, percentage times mass plus percentage times mass divided by 100. Let's write that out again, okay? Percentage abundance multiplied by the mass of the isotope plus the percentage abundance multiplied by the mass of the isotope divided by 100, and that's what we need to do, okay? So we're told it has 90% of neon 20, so 90% times neon 20, plus 10% times 22, 10% times 22, divided by 100. And let's work that out a stage at a time, just to be sure that we get all the marks, I think. Okay, so 90 times 20, just doing that in my head, that's 1800. Plus 10 times 22, that's 220 in my head. We can check all that on a calculator. And I always think it's good just to do it in your head and check it on a calculator, because that way you're very, very unlikely to get it wrong. Okay, so 90 times 20 we said, didn't we? 90 times 20. I said that was 1800. It is. Next one, 10 times 22. 10 times 22 equals 220. So my mental arithmetic's correct. Okay, and then we're going to divide that by 100. Okay, next step I'd like to do is, as I said, work that out. So we'll do that here. That's going to be 1800 and 200 is 2000, so 2020. 2020 divided by 100. Okay, let's just quickly just double check that in the calculator again. 1800 plus 220 equals 2020. That's what I've got. Divide that by 100 for our final answer. Equals 20.2. Equals 20.2. And that's what, coming back to the question, said. Why in this sample the neon has a relative atomic mass of 20.2? So we'd say the average mass, being this is a 6-mark question, I'll probably write it. The average mass of the atoms in this sample of the element are 20.2. So that's the relative atomic mass of this sample. Plenty of questions like that on the exam. Get this calculation absolutely right in your mind.